Hello, welcome to chapter 3.2. We're going to talk about methods that return objects. Once again, we're going through the book AP Computer Science Done Right, and it's available on Amazon. And my name is Alex Jafari. I'm the author of the book, and I'm joined here with Irfan. Hi, Irfan.
Hi Alex, how's it going?
It's going great. Do you want to get started?
Yes, let's start.
All right, so let's talk about this section. Just so you know, the concept that you're going to learn is called casting. But we're going to learn about it soon. So let's get started. All right, let's say, do you remember the person class that we had?
Yes, I do.
Excellent. And you remember that each person had a name. What else did they have?
Age,
They had an age, yep.
they had height,
Height, weight. Whoops. And then we used strings or integers or decimals, essentially numbers, to represent the rest of these things, right?
right.
Excellent. All right. So, Irfan, you live in Turkey, right?
Exactly.
Excellent. So, you measure your height in centimeters, correct?
Yes.
Let's say your visa comes and you are in the US. And in the US, you have to go to the doctor to, just do a normal checkup. And they ask for your height. And you say 191?
196, let's say.
196, let's say. All right, as if 191 is not tall enough. Let's say 196. And the doctor looks super confused. For some reason, the doctor doesn't know about centimeters. I don't know why. But they are trying to get your height in feet and inches. Are you familiar with this?
Makes sense, yes, I'm familiar with this.
Yeah, excellent. So it would be really difficult for the doctor to just keep Googling every time you give them a number. So, how should we represent height in feet and inches? How can we automate this?
We can design a method that returns the number of in centimeters to feet and inches, right?
All the way to the end. Okay. 1 second, let me see. Let's do gray. Okay. So one idea you might have is to represent feet and inches instead of centimeters, right? How would you represent feet and inches, the number? So like let's say this, I actually don't know what your height is in feet and inches, but let's say it's 6 foot, like 7. How should we represent this in the data world?
So it's going to be a decimal number?
Ah, right. So you might think, well, let's use decimals. So this would be like 6.7, right?
Yes.
But if you choose this, and let's say someone else comes along and he's actually 6'11, with our current decimal system, his height would be represented at 6.11, right?
Mm-hmm.
So in this scenario, 6'11 is actually shorter than 6'7, right?
Correct, yes.
Yeah, which is incorrect. So in actuality, this is feet and this is inches. So the fact that someone is 6'11 means that they're actually 4 inches taller than our already very tall 6'7 guy. Okay, so this decimal idea is not going to work, right?
Yeah.
Okay, so we're not going to be able to represent this with a decimal. And we already know we can't represent it with an int. And that's the only two ways that we have learned how to represent numbers, correct?
Yes, correct.
All right, so what to do? Well, do you remember from previous classes when we said when we have a complex information and we need to represent it, how do we represent it when the normal, string and number does not suffice. How do we represent complex information?
We create a class.
Yes, exactly. We represent complex information with classes. So we could have a class height. Okay, what should be in there?
What should be in there? A good question.
So think about the example of this height class. So you want it to be saying something like 6'7" or 6'11", right?
Mm-hmm.
So it's always like a feet and inch number, right?
Exactly.
Okay, does that help you with what fields we need for the height class?
Do we need two fields, one for feet and one for inch?
That's precisely right. Yeah, so we need a feet and we need an inch field. What should be the type of those two?
Each of them are a whole number, so I think it would be enough just an int, right?
Yes, exactly. So we're going to just do an int feet and int inch, right? And then we all know that a class needs a constructor, so that's simple enough. I'm not gonna write out the whole thing because at this point you should all know how to write the constructor. And that's essentially it, right?
Mm-hmm. Yeah.
Does that make sense?
It all makes sense.
Excellent. So now we have this new way of representing height in feet and inches. So now that we have this, let's go back to our person class. In our class person, where we used to have string name and so forth, and we used to have int height, what should we have here now?
We need to connect this class with the other class.
Right? Yeah, we want to connect the height class to the person class. So how do we do this?
Does it work if we write this dot height?
So this dot height would be in the constructor, right? This dot height would be in the constructor. But
how do we call it from another class?
So we can just say height. Have we not learned this before?
I think we have.
Okay. Yeah, because we had food and stuff, right? Yeah.
And also the closet thing.
The what thing?
The closet thing to represent the items from another class.
Yes. Yeah. So we could have height, and it would be the height in feet and inches. Does that ring a bell?
Yeah.
Okay.
Does.
So, but now, if I change it to height, if you go back to Turkey and you want to go to the doctor and you say, I'm 6'11", the doctor will definitely have no idea what you're saying because that's not a real thing. So, what should we do?
I don't know. If we just call the height in the person class, it comes like in centimeters, doesn't it?
Well, no, because we're changing it to the height in feet and inches. So what we really want to do is we want to pick one for the person class. So let's say we are going to keep it as int. And we're going to say it's in centimeters.
All right.
But then later in the class, we can have a method. A method that convert this person's height excuse me, from centimeters to feet and inches. Does that make sense?
All right. Yes. How are we gonna design this method?
All right. So, you know my favorite words, the design recipe.
Okay.
I'm going to write this in blue because this is new. All right. What's the first step in the design recipe?
We write a comment of how are we gonna do in the
Yes,
design method?
exactly. So this is the first step. This is our comment. Convert this person's height from centimeters to feet and inches. Okay. What's the second step? I think it's the signature, right?
It is the signature. Yeah.
Yes. So how do we write the signature?
So we want it from centimeters to be in feet. So anyway, it's gonna be an int, right?
So it's the input is going to be an int. What's the output?
Also an int.
Well, we just created a whole new class for height, right? How is it going to be an int? How are you going to represent 5'11" as an int?
Yeah, you're right.
So what is the output?
Double is going to be a double.
Didn't we say if we write it as a double,
Indeed.
it would be like decimals? So what should the output be?
From an int to what? What are the other ways to represent numbers?
Yeah, what are other ways to represent numbers or complex information? What are the other ways to represent complex information?
Create a new class.
Right? So now that we have this new class called height, what should our signature be? It's going to be an int to...
Int to height.
Yes, exactly. Our output can be height. This is the first time we're doing this. And
Our
it's going to be
output is a class.
Our output is a class, yes.
Okay.
Yeah, so this is the whole new concept that we're learning in this section. We're learning how to have outputs as a class.
Mm-hmm.
And if you actually look into this, like a string is also a class. We just haven't created that class. Java has created it.
Oh yeah.
So height is also a class. How do we write signatures in Java?
First an input, then the double, and what is the next step?
So the first is going to be the output, right? Remember if we had like something like public, for example, output, which is going to be height, and then it's going to be the name of the method.
Yeah, right.
So it's going to be convert to feet, and then it's going to take in the input, right?
Mm-hmm.
What should the input be?
The input is an int. The input is height in centimeters.
Right. Given that I'm writing this method in the person class, do I need this?
No.
No, because I can just access it through the fields, right?
Mm-hmm.
Okay. What's the next step in the design recipe?
So after the signature, we need an example.
Yes, exactly. We need an example. So if I have an example of 167 centimeters, what do I expect to get? Or let's say that's like 5'7".
Okay.
So I expect to get a class height with the feet to be 5 and the inch field to be 7, right?
Mm-hmm. Yeah.
Okay, excellent. Now that we have our example, what's the next step?
What is the next step?
The next step is coding. That's step 4. So that was step 3 that I just like erased. But step 4 is actually coding it. All right, now that we have our examples and our signature, it should be fairly straightforward to code it. How do we code this? So we said, what should the input be?
Height in centimeters.
Height in centimeters. How do I get access to that?
This that height.
This dot height. Exactly. And there's a formula in how to actually access the, how to actually convert centimeters to feet. So you actually need to divide it by 2.54, and then that gives you the height in inches.
Okay.
And then when you do have it in inches, then you want to figure out what the
How many
feet
feet would it be?
Yes, exactly. And there are 12 inches in 1 feet. So then you would divide this by 12. And then whatever is remaining essentially would be your inches. So this would be like your feet. And then whatever is remaining would be your inches. And then you can create a new height class with that feet and inches. Does that make sense?
Okay, makes sense.
Okay, excellent. So let's get started. So first, I want to have all inches. So what is the type of all inches?
We said they're both ints.
Right, so it should be an int since it's going to be a whole number. So it's going to be int all inches. And it's going to be this dot height
divided by 2.54.
Right. At this point, Java will give you an error. You know why?
Why?
Because you're expecting an int, and when you divide a number by a decimal, you are going to get a decimal, right? So Java's going to say, I have a double and you want an int, and I don't know what to do with it.
So how are we going to solve it?
Right. This is where the big thing comes in. It's called casting. Casting means I just write the type that I want in parentheses next to the type. And this tells Java, hey, you know this decimal number you have? Actually change it to a whole number. So drop the decimal. So if like you got something like 167.3, drop the decimal and just give me 167.
Okay.
This is so that you know you're explicitly changing the number and you're explicitly deciding to not use the remaining information.
It's not pretty accurate.
Exactly. So, since we're dealing with only whole numbers and we are not, saying our height in decimals, we're not saying I'm 167 inches, 67 centimeters and 3.3, then we can say it's okay. We're deciding to lose information and we're going to cast it to an int. Does that make sense?
Okay, yes, makes sense.
Excellent. Then, now that we have our all inches, then we want to have it feet. What should the feet be?
It's also an int.
It's also an int, exactly.
Int feet. Gives us all inches. You said it's 12, so divided by 12.
Yes, precisely. All right, so that's our feet. And then how do I calculate the remaining inches?
I don't understand what you mean.
So, remember, if I'm 167, let's say, and I divide it by 2.54, let's say that ends up being 5.
It's 5 feet.
5 feet, yes, exactly. But I'm not just 5 feet, right? Because 5 feet is a lot less than 167.
Yeah.
I should be 5 feet something. I'm trying to calculate that something.
Okay, now I get it.
Right?
Yeah.
So I know that I'm 5 feet and I'm essentially just calculating the remainder of it, which means all I gotta do is I go back to this all inches, and I gotta subtract this feet times 12.
Yeah, makes sense.
Does that make sense, right? Because this is essentially you're trying to you're trying to see, okay, what is 5 feet in inches? Let's say it's 100 and
Like
it's
50
like
maybe.
150. Well, it wouldn't be 150. 1 second. 127.
All right.
So let's say if it's 127 inches, I need the remaining of that. So I need the other 40. Wait, that doesn't make sense. Because 40 is more than 12.
Like when we divide it by 12, there is a remaining number of inches except the feet.
Yeah. But we need to... Let's go through an example. Let's go through an example, actually. Let's say you are 100 centimeters. Okay? 100 centimeters divided by 2.54.
Maybe less than 50.
It's going to be 39.37 whatever. Okay? So
This is the feet. This is the inch.
this
excuse
is...
me.
Oh, it shouldn't be divided. Yeah, it is. Yes, it is. It is. It is. So this is... I am like... If you are 100 centimeters, you are 39 inches. Okay?
Mm-hmm.
Now you're trying to see, okay, how many feet and inches are you? So then you divide 39. You drop this because it's an int, right?
Mm-hmm.
You divide 39
By 12.
by 12. Exactly. You get 3. Okay?
Mm-hmm.
So you know for sure you're 3 feet tall. But if you just leave it at that, 3 feet tall means you're only 36 inches, right? Because 3 times 12 is 36.
Yeah.
Okay, but that's not how tall you are. You're 39. So you do 39 minus 3 times 12, which is 36, and you get 3
It's the remaining inches.
is the remaining inches. So then you are 3'3".
Okay.
Does that make sense?
Yeah.
All right, that's 100 centimeters because it's easier to calculate that. Let me erase this. We have this problem every time. All right, great. Okay, so now that we know how the math works, so we know that these are the feet, these are the inches. Now, how do I finish the method? Let me scroll up a little bit. So remember, we're saying public height convert to feet. What does that mean? It means that Java's expecting height,
Mm-hmm.
right?
Yeah.
So what's the keyword that we need to use?
We need to use return.
Right. We're going to use return. And what are we returning?
A new height.
A new height, exactly. And we're going to pass in the feet and inches. Does that all make sense?
All makes sense.
Excellent. So now we know that methods can return a class, essentially. Are you ready for your favorite part of the program?
Let's do it.
All right, we're going to learn about our homework. Okay, your homework number 1. So, people usually measure their foods in, the food's weight, I should say, in grams or ounces, right?
Mm-hmm.
Okay, but it's Thanksgiving, so happy Thanksgiving, and all sense of food measuring is lost because people just want to eat. However, they want to know how much they've consumed in number of turkeys and feathers. So each turkey is about 2 kilograms, and each feather is about 100 grams. So what I want you to do is design a method that takes a weight in grams and returns it in Thanksgiving measures. So if you had some lunch, I want to know how much did you have in turkey and feather.
Okay.
Does that make sense?
Yeah.
I'm excited for you to do this. And then I'm excited for you to eat some turkey. All right, the second question. Have you had boba tea?
Nope, unfortunately.
Oh my goodness. Okay, I highly recommend boba tea. And then if you do have some boba tea, they always have a cash register, unless they're a charity, in which case please let me know. The cash register displays how many cents a customer is owed. And if you know the cents, the cashier needs to know how many quarters, how many dimes, nickels, it should give a customer.
Mm-hmm.
So let me actually clarify these because not everyone is in the US and not everyone is familiar with these. So quarters are equal to 25 cents. Dimes are equal to 10 cents. Nickels are equal to 5 cents. And pennies or cents are equal to
1 cent.
1 cent. Exactly. So you want to develop a representation of change, essentially, that will give you the number of coins to equal a cent number. And essentially, you're trying to optimize for least amount of coins. So you should give as many quarters as you can, then dimes, then nickels, and then lastly, cents. All right. Does this all make sense?
All makes sense.
Great. I'm excited for you to do this. Have a great day.
You too. Bye.
Bye.